Long ago, we were told that the world was running out of IP addresses. Since then, several technologies were introduced and adopted. Currently, IPv4 is still much more popular than IPv6, mainly thanks to NAT, or more specifically, Masquerade NAT. In this Ubiquiti document, you can find the Masquerade NAT's definition. It translates a group of IP addresses to the primary IP address associated with an interface. We all have all sorts of devices that need access to internet, but normally at home we only have one router or gateway and only have one public IP address. But all of our devices, they can get access to internet or due to this type of NAT. It has different names for different vendors or operating systems. In Linux world, it's normally called Masquerade. The name Masquerade already implies that it will hide everything behind the primary IP address. Before starting our testing, just a warning: if you want to mess up with your NAT setting, especially the Masquerade rules, be very careful, because if you use the remote access method to access your UniFi network controller remotely from internet, if you have something wrong with your Masquerade rules, you may lose the access to your network controller. It will be very troublesome to recover if you are not on site. Okay, just a warning. In UniFi Network Controller, if we go to Settings, then Routing, there's a tab called NAT. It lists 3 different types of NAT. The first one is Masquerade. By default, if you do not do anything, as long as you have internet, you will have this default Masquerade rules generated already. So you can see the log sign there, so you cannot really edit them. We will talk about these 2 default rules later. Just to start our Masquerade rule testing, let me start from scratch instead of using these 2 existing rules. To remove these 2, it's very simple. See the global NAT setting. We simply uncheck Alter, turn it off, apply changes, then see, they are gone. So now we have a clean environment and we have 0 Masquerade rule at this moment. So now if I try to access internet from my local network, let's see what's the result. For example, from this VLAN 10 machine, if I try to ping 8888, see, it failed, right? Because we don't have Masquerade rule. So the local network IP address is not public IP address. It cannot directly access internet. Right now, let's manually create a Masquerade rule. Make sure you have the type Masquerade selected, give it a name. Then for protocol, because we are talking about internet, so I don't want to restrict it. For interface, it is talking about the out interface. We want to enable internet access for my local network devices. So when their traffic go out of this one part, I want to do the translation. So that's why the interface is the out interface. And here by default, I want to use the primary one part. So that's why the default selection is okay. For source, let's make it more interesting. Let's say I only want to give VLAN 20 the internet access instead of VLAN 10. So here I restrict VLAN 20. Then that's it. I don't want to change anything else. Let me add it. Okay, you can see it's up and running. Then we can easily test it out from this VLAN 20 machine. Let me ping 8888. Yeah, it's pingable. Then from the VLAN 10 machine, do the same thing. It still cannot access internet because in the Masquerade NAT rule, we only enabled the source from VLAN 20. Okay, so you can see how easy a Masquerade rule is, right? But you may wonder how it works internally, where the translation of IP addresses happen. Let me SSH into the gateway. First, let's see how internally the Masquerade rule is implemented. Let me go to IP tables, and I only want to show the NAT table. I want to list the details. You can see there are a lot of rules included already, but 3 of them are related to Masquerade rules. For these 2, you may wonder where they come from because we only created one Masquerade rule, right? So we will discuss these 2 later. In fact, even though we disabled the global NAT setting, the rules are still here. For now, let's focus on the first one. See, this one is the result of our new Masquerade rule. Target is Masquerade, so the Linux kernel knows what to do. Basically, it will do the IP address translation. Where to do the translation? See, the out interface is eth0. In my case, it's the primary one part. And only if the source is in the VLAN 20 network, and it doesn't care about the destination. So what this Masquerade rule says is, if the traffic is going out of the primary one part, if it comes from VLAN 20, it will do the Masquerade translate, which means it will translate the local private IP address to the public IP address, which is associated with this eth0 one part. That's exactly what we want to achieve by using this newly created Masquerade rule, right? Then let's see it in action in the system. Let me run this TCP dump command. What I'm saying is I want to list the traffic for all interfaces as long as the host is about 9999. Okay, now the monitor session is running. In the right side, from the 2 Linux machines, let me try the dig command. So from the VLAN 10 machine, let me run this command. What I'm saying is I want to do the DNS query for x.com, and I want to use the 9999 as the DNS server. It doesn't matter what's my operating system setting, what's the UniFi gateway setting about DNS, I don't care. I want to use this 9999 to do my DNS query. Okay, then let me run it. Even though the right side Linux is still hanging there, the left side, we can already see some traffic. So then, of course, the dig command from VLAN 10 will fail. Why? Because in our Masquerade NAT rule, we only enabled the source for VLAN 20. So, of course, VLAN 10 will fail. But let's examine the detailed captured packets. See, starting from this one, the interface is eth310. S3 is the LAN part of the UniFi gateway. .10 means it's VLAN 10, and the source is my Linux machine. This is the port number for the dig command, and then this is the destination, which is 9999, and then the domain here is the destination part, which is 53 for DNS. So this first packet makes sense, and then the second one, the BR10, is the bridge device for VLAN 10. The source and the destination remain the same, no translation, which means there's no NAT rule applied, right? And then the third one is the reason why the dig command failed. The interface is eth0, is the one part, the primary one part, and the direction is out, so it's visiting internet already. And the destination, of course, is 9999, but the source IP address is my local private IP address. That's why this packet won't work. It didn't go through, and that's why in the right side, the dig command failed. Then it tried 3 times in total. They all failed. Then let's do the same thing, but from the VLAN 20 machine. Dig x.com and using 9999 as DNS server. It was successful. It got the result back, and the server was 9999, right? And then let's check the captured packets. The first one, similarly, is from VLAN 20 from the Linux machine to 9999. The second packet is 20 bridge, no surprise. And the third one, see what happened? The interface is the primary one part. The direction is out. See the address. Now it becomes the primary one part IP address. By the way, I'm running the lab environment behind my main router of my home. So that's why here, even though this IP address is for my primary one part, it's still a private network IP address, right? But it doesn't matter because it is the IP address for my one part. You already see the translation. So it translates from this VLAN 20 Linux machine's IP address to this one port IP address, right? If you check the port number, it remains the same. It doesn't really alter the port number. It will use the original port number from your private network. Then the destination is the same 9999, and the destination port number is the same 53 port. The following packets, they are just the normal replies from the 9999, and then it's transferred back to my VLAN 20 Linux machine. Okay, for VLAN 20 machine, the dig was successful. So the only difference between the VLAN 10 and the VLAN 20 testings happened in the third packet. For VLAN 10, the translation didn't happen. For VLAN 20, it happened, all because of our Masquerade rule we defined. This is how the Masquerade NAT rule work in action. But you may wonder, so when the traffic is going out of the one part, yes, the translation happened, but when the reply come back, see here, the 9999 DNS server, it doesn't know our internal VLAN 20 machine, right? It will send back the reply to this one part IP address. And then see the next packet. Here, another translation happens. So this one part IP address was translated back to this internal VLAN 20 Linux client's IP address. You may wonder how the system remember the mapping between the local private network IP address and the public IP address, how the mapping happens. So to show you that, let me run another command. So let me stop capturing. What I want to show you is the connection tracking for Linux. So I want to list the content, but I only want to show you the SNAT related tracking information. Technically, Masquerade rule is a special SNAT rule. So that's why here I want to only show the source net related tracking. I'm only interested in 9999 related mapping. Okay, let me write now. You can see no mappings returned at all. Why? Because at this moment, there's no back and forth traffic happening with 9999 yet. From the VLAN 20 machine, let me do the same dig command. Okay, here, let me run the same command. See, this time is different. It returned one entry. So let's see what's recorded here. The protocol is UDP because it's DNS. You can see two pairs of source and destination information. This is the first pair, and then this is the second pair. Okay, so let's see what's the difference between these two. See the first pair? The source is the VLAN 20 Linux machine's private IP address. Destination is 9999, and the source part is this number. Destination part is 53. So this pair of source and destination is the situation for my private network. Then see the next pair. This time the source is 9999. It's the other way, right? From internet. And the destination, see, this time is different. The destination is the one part of my gateway. The destination is not my private network. So then the source part is 53 for DNS. The destination part, see this part number, is the same as the part number here because they are related, right? They are just mapping. In this way, by maintaining these two pairs, the system knows how to map the private IP address and the public IP address, and then the system can track the connection, the state. If I do the same thing from the VLAN 10 machine, digx.com, and then in the left side, if I try to run the same command, you can see nothing's returned because there's no SNAT related tracking information at all. Because of our Masquerade rule, we are not doing the translation for VLAN 10. That's why in the connection tracking, you won't find anything. Okay, I also prepared this slide. You can see how the mapping works. You have your private IP address, you have a port number from your private network, but when the traffic goes out of your gateway, the IP address will be translated to the one part's IP address, but the port number will remain the same in our testing. In this way, you can see we enabled one-to-many NAT translation. That's why Masquerade NAT is also referred as NAT overload in some cases. Remember when we checked the IP tables, we saw two other Masquerade rules, right? So now it's time to look into them. They are the result of the default setting. At the very beginning, we disabled the global NAT settings, right? The two generated Masquerade rules are still there. Then you may wonder whether they will impact the routing. No, they won't. The reason is you may notice the other interesting rule. It's immediately after the Masquerade rule, right? This target is return, which means it will not continue the remaining rules if the conditions are met. So then let's see what are the conditions. The only condition is here. As long as the IP address, the source IP address belongs to the subnets, which should be skipped, this rule will be executed. It will do what? It will do nothing, right? That's exactly what this skip means. But let's see what's inside this IP set. Okay, it's defined using two subsets. Let's see what's inside the first one. Okay, now it's clear. See what are the subnets which should be skipped? They are all the subnets for my internal VLANs. Why is that? Because we disabled the global NAT setting. Here we say off, which means for all the VLANs, for all the internal subnets, we want to skip NAT support. Okay? At the end of the video, let's examine the default Masquerade rules. Let me remove the testing rule we created for this video. Then let me enable the global NAT settings again. See, right after I enable it, the two built-in Masquerade rules, they reappear. Before going to the backend, let's first check from the UI side what interesting things we can find from these two built-in Masquerade rules. You can see there are two rules generated. Because for this particular gateway I use is UXG Pro, it has two one part. About the IP address, let me show you where these two IP addresses come from. So if we go to internet, for each part, you can see I specified multiple static IP addresses. This 191 is the main IP address, and there are 3 additional IP addresses. And the similar situation for the other one part. And then about source, if you move your cursor to the information icon, you can see, okay, for the first one part, it has 4 networks. But why for the second one part, there are 5? You can see the only difference is the OpenVPN server. But why only for 1, 2, I have the OpenVPN server as one of the source networks? If we check the OpenVPN setting, you can see here for server address, I configured it to use 1, 2. That's why here they have different networks. And as you know, they are showing the lock icons. They are not really editable. But what if we added new VLANs or we changed, for example, the VPN settings, right? Don't worry about that because the system will automatically adjust the sources. For example, here for the global NAT setting, let me customize. Let me say I don't want to provide NAT service to VLAN 30. Once it's active, see what's changed? For the source configuration, they are automatically reduced. You can see VLAN 30 disappeared from both rules. So don't worry about the dynamic configuration change. The system will automatically cover it. Okay, let me change it back. Having examined the UI, let's go to the backend. Let me run the same command, iptables. See, this time, what's the difference? Originally, for this chain, you see 4 rules, right? But now you only see 2. These 2 are corresponding to the 2 built-in rules. So let's see how they are defined. Of course, the target is Masquerade, the protocol is OR, and as you can see, the out interface, first one part and the second one part, respectively. And for source and destination, they both have anywhere. However, here here you have this interesting match set. From the name, you can guess this set is for the IP address of the primary one part. This is for the IP addresses for the second one part. And these two match set, they are both for source. However, it's very easy to miss this super important sign. It's a exclamation sign. It means not. So basically, this condition means as long as the source is not the IP address for the one part, the masquerade rule will apply. Think about it. If there's a packet going out of the one part, if the source is the private network, then of course you want to apply the masquerade rule, right? But if the traffic is not from the LAN, what if the traffic is directly from the gateway's one part? For example, the gateway can initiate some internet activities directly from the one part. If that's the case, you do not want to apply the masquerade rule because the NAT doesn't help. The original source IP address is already the public IP address, right? So that's what this exclamation sign means. Okay, I hope it's clear. Basically, these two rules remain the same. It doesn't matter whether you disable the global NAT or whether you add, delete VLAN or reconfigure the VPN. No matter how you change them, these two rules remain the same. But the content of these two sets may change accordingly based on your public IP configurations for the two one parts. Okay, this is a brief discussion about the two built-in IP table rules. Okay, this is the end of this video. Thanks for watching.